application of right? Because if we have understood this trigonometry part, then it is better to do this application of right? So, yeah, just that. In application of trigonometry, what we need to find out. So let's say that we know that we have a right angle triangle, right? We have a right angle triangle and it has three sides. So in application of trigonometry, whatever we have learned from introduction to trigonometry, we will apply those. So in application of trigonometry, right, we have to remember that we have a right angle triangle, right? And let's say if this is theta, so this is 90 degrees, so this is hypotenuse, right? This is hypotenuse, and let's call it as H. This is perpendicular. Let's call it as P, and this is the base, right? Let's call it as base. So from the introduction of trigonometry, we know that sine theta will relate what? Sine theta will relate which two sides? What is sine theta? Rifa? Yes. What is sine theta? In a ratio
P by H.
P by H, right? It's absolutely correct. So this is P by H. So sine theta relates the perpendicular with the hypotenuse. Similarly, we have cos theta. So that relates base with hypotenuse, and we have the last one, tan theta, which relates perpendicular to base. So in the application of trigonometry, we will only need these three, right? So we have to remember that what relates perpendicular to hypotenuse, what relates base to hypotenuse, what relates perpendicular to base. So these are three things we have to do. And let's say that we are on the ground, right? So this is the ground, and some bird is flying. Right? So let's say some bird is flying. Okay, and let's say this is the point of observation, right? So maybe we can write this thing, right? Maybe this is some height of the person. So let's say this is some person, and he has to look what? So this person has to look up, right? So to see this bird, the person has to look up. So the horizontal line, right? So this is the horizontal line of this person, and whatever line that is connecting these two objects, right? So this is called the line of sight. So from whatever line we are seeing this object, that is called the line of sight. And are we looking up or looking down? What we are doing? We are looking up, right? So the angle with which we are looking up with the horizontal, that angle would be called the angle of elevation. So this is called as the angle of elevation. Is this thing clear, Rifa? Is this thing clear?
Yeah, so basically, when the person is looking at the object, it's called angle of elevation.
Yeah, so if the person is looking up, right? So this person is on the ground, let's say he is on the ground or maybe on the roof. So then this will be called, whenever the person is looking up, that would be called angle of elevation. So first we have to figure out what is the line of sight, what is the horizontal. And if we are looking above the horizontal, then that is angle of elevation. And there is this another case also. So let's say so this is some building, right? Some tower. And the person is standing there, right? So this is roof, and this is the bottom of the tower or whatever. And some object is in here. So let's say some car is in here, right? So if we are looking at the car, so let's say this is the person, right? So his horizontal line would be this. Now this is the horizontal, right? So this is horizontal. And to see this car, we have to look down, right? So this is the line which is connecting the observer. This is the observer, right? And this is the object that we are observing, right? So then again, this line would be called what? This is again line of sight. So what we are doing? Are we looking up or are we looking down? So with this horizontal,
We are
we
looking
we are
down.
looking down, right? So from this horizontal and from this line, whatever the angle is it making, so that angle would be called the angle of depression. Okay. So only these are the crucial points to remember in the application. So the whole chapter revolves around the angle of elevation, angle of depression, line of sight, and the trigonometric ratio. So we have to remember only these. So you please note down these things,
Yeah.
and then we will do the questions. Please note it down, and whenever you want me to scroll down, so I can put this. Whenever you want me to scroll down, we can put this. Yeah, whenever we are going in a long future.
I noted.
Okay, so yeah, now let us do some questions. So let us start with the first question. So a circus artist is climbing a 20-meter long, which is tightly stretched and tied from the top of a vertical pole, right? So first we have to write or make a diagram of a pole, right? So from this pole, this is the top of the pole, and this is the bottom. So from this pole, one rope is attached, right? And which is tightly stretched and tied from the top of a vertical pole to the ground. So this is the ground, right? So this is the rope, right? Now find the height of the pole if the angle made by the rope with the ground level is 30 degrees. So this is the rope and this is making an angle of 30 degrees with this ground, right? And we know that the rope length is 20 meters. So we know this 20-meter length rope, we know this angle, and we want to find out the height of the pole. So this is the height, right? Height of the pole that we want to find out. So can you tell me what is this thing? So this is hypotenuse that we know, right?
This the perpendicular. Height is the
So this is a perpendicular, absolutely correct. So we have to relate this perpendicular with the hypotenuse. What relates the perpendicular with the hypotenuse?
Sine value. So,
Sine angle, right? So sine theta, that would be B by H. Sine 30 is how much?
1/2.
Yeah, absolutely correct. This is 1 by 2. P we want to find out, that is the height, divided by H, that is 20. So height would be 20 by 2, which is 10. So height would be 10 meters. This is the height of please note it down and then the next. Yeah, whenever you have noted it down, please tell.
1 second. Height is 20.
Height is 10, right? Height is 10. This is
No, no,
hypotenuse.
height is equal to 20/2.
Yeah, 20 by 2, that is 10, right? How did we
And
get 20 by
no, no, see, the perpendicular is the height, right?
2? Yeah,
So did they give any value of height in the question?
they're asking the height, right? Find the height of the
Yeah,
height.
so we know the value of hypotenuse, which is 20. So
Yeah, so we know the length of
20
the.
by,
Yeah,
okay, finished.
okay, so then let us if a tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle 30 degrees. Right. So let's say we have some trees, right? Okay, so let me. So we have this tree, right? This is the tree, and some storm comes, right? And then this tree breaks. So let's say it breaks from here, right? So this is the total height of the tree, right? This is the tree, right? So it breaks from here, and then it is hanging on the ground, right? By making some angle. So now this is the top of the tree, right? Now this top it has reached here. So now this is the top of the tree. This top of the tree is making an angle how much? So this 30 degree, right? So this is making an angle 30 degree. And what do we know? the distance between the foot of the tree, so this is the foot of the tree, right? And the top of the tree. So this distance is given, and that is 8 meters, right? So we have to find out the height of the tree. So remember, the height of the tree is this thing, but this height has dropped down and it has reached, let's say, if this is y, so this is now the y, right? The broken part. So this is the broken part, and this is the unbroken part. So we have to calculate this x and y, because the height of the tree would be what? That would be x plus y. Correct? Here.
Yeah.
So let's say if you want to find out y is a hypotenuse, right? This base is given, and this hypotenuse is given. So cos 30 degree, that would be how much? Base by hypotenuse. So base
Right.
is,
Hypotenuse is not given, right? We
yeah,
have to find
that,
out the y.
yeah, this is what we have to find out. Why we have to find out? What base is given, right?
Then can it be p by b?
B by B.
But
B by B is tan,
yeah,
right?
it's tan. But base is also given, right? And here x is the
Un
perpendicular.
Yeah, so if I want to calculate x, then I will use this tan. Yeah, absolutely correct.
We can put tan.
Yeah, yeah. So for x, we can put tan. But if
Alright.
you want to find out x, currently we are calculating this y, right? So firstly, we want to find this y. Okay, so cos 30 is root 3 by 2, which is 8 by y.
Is it
So
possible if we can find the value of x with Pythagoras theorem?
x, yeah, that we can also do. If we have found out this y, then we can use this Pythagoras theorem. But now we know trigonometry, so that is easy, right? Whatever method we use, if it's the answer. Okay, so we have to calculate y. So this thing goes in here. This thing comes down. So this is 8 into 2 by. Now we have to rationalize this thing. So multiply by root 3, divide by 2. So this is 16 root 3 by 3. This is y. Now for let's say this is a part. B part is tan 30. So tan 30 is B by B. B is X, B is 8, right? So this would be how much? Tan 30 is how much? 1 by, right? So this is B is X, this is 8. So X would be how much? X would be 8 by root 3. So multiply by root 3, divide by root 3. So 8 root 3 by 3. So this is our X. Now, if you want to calculate the height, so height of the tree, that is x plus y. So 8 root 3 by 3 plus 16 root 3 by 3. So 3 is LCM, 8 root 3 plus 16 root 3. So 8x plus 16x, that would be uh, right 24 root 3 by 3. It would be 8. So the height of the tree would be 8. This is meters. So that is the height of. Is this thing not clear? Rifa, is this thing not clear?
Yes.
And please, no. I will come in up. Right.
Finish. Hello? Hello? Hello?
Not bad. So whenever you have noted it down.
Hello? Finished.
Yes. Yeah, finished. Okay, so now let us. So the third question. Let us. So a contractor plans to install slides, right? So slides have what? Slides have these kinds of things. This is the slide, right? This is the slide. So this is the slide. Let's say this is slide one, and this is the slide. So a contractor plans to install two slides for the children to play in the park. For the children below the age of 5 years, this is below 5 years, and this is above 5 years, right? So for the children below the age of 5 years, she prefers to have a slide whose top is at a height of 1.5 meter. So this is the top of first time. So this is 1.5 meter, right? For the below edge and is inclined at an angle of 30 degrees to the ground. So this is the angle. And whereas for the elder children, she wants to have a steep slide at a height of 3 meters. So this is 3 meters, right? This is 3 meter at an angle of 60. Okay, so this should be this diagram. This is so what should be the length of this slide in each case? So we have to find length 1 and length. These two things we have to find out, right? Okay, so what are these things? What are these sides in case of right angle line? Yes, what is L1 and L2 in the case of right angle triangle? So these are hypotenuse, right? These are hypotenuse. This is perpendicular. So we have to relate perpendicular with the hypotenuse. And what trigonometric ratio relates perpendicular with the hypotenuse? Sine theta. So let's say case first. Case first is sine 30. That is perpendicular by hypotenuse, which is 1.5 and then 10 1. Right. So sine 30 is half. This is 1.5, then 1. So then 1 would be 1.5 into 2, which is 3 meters. So the first slide length below 5 years, that would be 3 meters. And for the second case, again, what would be the length of the slide? So sine 60 again, that would be P by H. P is now 3 meters. H is L2 that we want to calculate. So sine 60 is root 3 by 2. This is 3 by L2. So L2 would be 2 into 3 by. So if we rationalize this thing, 3 by 3. So this is 2 into 3, 3 by 3. 3 will cancel and this is 2 root 3. So this is the length of the second elder one. Is this thing clear, Rifa? Yes, is it clear?
Yeah, yeah. So here you use sign value PV.
Yeah, because
So
we have,
okay, so whenever there is like whenever the value of the it is given, then it means like it is P by H, our cost value.
yeah. So in this case, what were the given values? So in this case, perpendicular was given, right? Perpendicular was given, and they were asking hypotenuse was asked, right? So we need to relate P and H. So what relates P and H?
Sign.
That is why we used sine theta, right? Because we wanted to relate perpendicular and hypotenuse. If in the question this distance was given, right, then we will relate base with the hypotenuse, so then we will need cos theta. But in this question, they stated or they gave us perpendicular, and they wanted us to calculate the hypotenuse. That is why we used sine. Clear?
Yeah.
Okay, please note it down, and then we will next set of questions.
Shouldn't the second part be 6 root 3 by 3?
Yeah, so you want to write 6 root 3 by 3. But 6 can be cancelled by 3, right? 6 root 3, right? 6 root 3 by 3. But we can cancel this 3 with 6.
Yeah,
It is whenever we can simplify, then we should write this simplify, right?
you finished.
Okay, then there is the angle of elevation of the top of tower from a point on the ground, which is 30 meter away from the find the height of tower. So we have ground and we have a tower, right? So let us make a tower on the ground. So this is the tower. This is the foot of the tower. This is the top of the tower. Now from this top, right, there is a point on the ground. So the angle of elevation of the top of a tower from a point on the ground. So we have a point on the ground. From this point, we have angle of elevation. So we are looking up, right? So this thing is how much? 30
30.
degrees. And which is,
It's 30
yeah, so the angle of elevation of a tower from a point on the ground. This point, which is 30 meters away from the foot of the tower. So this point is 30 meters away from the foot of the tower, right? So this length is given. So base is given, right? Now what are they asking? They are asking the height of the tower. So they are asking the height of the tower, which is perpendicular. So what relates perpendicular and base?
tan.
So we will write, yeah, good. So we will write tan theta or tan 30 degree is P by P. P is height that we want to calculate. P is 30. So tan 30 is 1 by root 2 and height by 30. So height is 30 by root 3. Again, if we rationalize this thing, so this is 30 root 2 by 3, which is 10. This is the height of the tower. Yes, so this application of trigonometry would be very easy. Right? We just have to make the diagram. Diagrams are important. Please note it down and then we'll do the other question.
You're finished.
Then let us okay. This is the question. So a kite is flying at a height of 60 meters above the ground. So we have the kite, right, which is flying, and this is flying. This is the ground, right, 60 meters from the ground. The string attached to the kite is temporarily tied to a point on the ground. So there is this string which is tied to this kite, right? The inclination of the string with the ground is 60 degrees. So this is the string, and its inclination is 60. Find the length of the string, assuming that there is no slack in the string. So we have to find this hypotenuse, right? This perpendicular is given, this hypotenuse we want to find out. So what would be the trigonometric ratio that we would use?
So perpendicular hypotenuse sine.
Sine 60. Yeah, so absolutely correct. So sine 60 is perpendicular by hypotenuse. Perpendicular is 60, hypotenuse we want to calculate, which is the length of the string. Right, so sine 60 is root 3 by
Root
2.
3.
This is 60 and string length. So string would be how much? 60 into 2 by 3. Again, we rationalize this thing. This will become 60 into 2 divided by 3. So this is 20. So 40 root, this is 40 root. This would be the answer. Okay, please note it down. And now, whenever you have noted it down,
Yeah, finished.
stop at here and yeah, you can continue.